This video is about how to disassemble and test the electrical side of, this happens to be a Toyota alternator, but the principle would apply to probably just about any alternator really. First of all, very simple, just take it apart. Take the heat shield off. Once you've got that covered off, you can see the main parts of the alternator. We have the rectifier section, the brushes, the voltage regulator here. Underneath here we have the stator, and the central part is the rotor. So let's get a screwdriver and take those apart. The hardest part to test on any of these is the voltage regulator. But if all your other parts test correctly, you're reasonably safe to assume it's the voltage regulator which is faulty. That's your voltage regulator there. There's some reference numbers on the back. You can buy these parts separately, I've seen them online. Usual places, eBay or AliExpress if you want to wait a bit longer. Or there's independent places that will sell them. That's the rectifier unit. These are your slip rings. See, these have a little bit of wear on them. Not too bad though. Quite reasonable. Bearings sound good. If you've got a rumbling noise when you spin the alternator, it means your bearings have gone. It is possible to replace them. There's one in the back here and there's another one in the front. You have to disassemble this, take the pulley off. Generally you'll need a small puller just to pull the bearings out, then press the new ones in place. But this one seems fine. I'm not going to disassemble this any further because I just want to check the electrical side of this. So the first thing we can do here is we can check the rotor to make sure we have continuity through it and to make sure we have no short circuits. Now the easiest way to check that, just need a multimeter, and you want to set it on an ohms reading, which is that. Mine also beeps, but it gives me a continuity and an ohms reading. My leads are actually measuring, well, depending on where I touch them, that is. about 0.3 ohms. Okay. Now if we measure between one pole of the stator and the other, hopefully we get a reading of about 5 to 6 ohms. So let's see what we get. We've got 3.2, so this is a heavier duty one than I anticipated. But that's not too bad. Now we also need to check that it's not shorting to the casing. So we will check that on both sides. And that appears to be fine. And we have continuity through the actual winding itself. The other thing we need to check is the stator. And the stator is the big coil, the basket type winding that runs around the outside of the alternator. Now there's 3 of these windings and they all join together on the C terminal, which is this one. So you've got 1 winding, 2 windings, 3 windings, and this is your common terminal here. We should get continuity from this terminal to all of the others. So let's check that. Got a reading of about 0.1 ohm. These are quite thick cables, so don't expect much in the way of resistance here. Just barely 0.1 ohms. Let's try this one. Again, about the same, 0 to 0.1 ohms, and this one. About the same. And again, we want to check that these aren't shorted down to ground. So we check that from the common. That should check all of them together. And now we have a good reading. So I think we can safely assume that the winding side of the alternator is okay. Stator and the rotor have checked out. So I think we can put that aside. I think our fault lies elsewhere. This is our brush unit. There's 2 brushes and 2 terminals here. It's worth just checking that the brushes are making contact with the terminals. And that one is. We go to the second one. And that one also is. So although they look a little worn, they are still working. Could do with replacing those. But that isn't why it's not working, because they're still contacting that okay. Okay. This is where it starts to get a little bit more in depth. This is the rectifier. This consists of 2 sets of 4 diodes. 1, 2, 3, 4. 1, 2, 3, 4. And what this does, this converts the alternating current generated by the stator and converts it into a DC current which the car can use to charge the battery. It's also known as a bridge rectifier, and anyone who's done any basic electronics will know what a bridge rectifier looks like. This is a bit of a strange shape. The diodes themselves are actually pressed in into the case here. Now you can buy these separately and it is possible to replace them. However, I've never done it and they look quite difficult to get out, so you might be better off just buying a replacement one of these if it turns out to be faulty. Anyway, let's continue. So we now want to set our meter here on a diode setting. It's currently on continuity, so to change mine I just move it to there, and I've got the diode symbol and there's a little V there. Now I should get a reading from our main post, our B+, down to here. And I don't seem to get. It's definitely working. I think I may have found the problem here. go. Okay, got 0.46 on that one. Okay, 0.4 on that one. Can't get anything on that one. I think this could be a problem here. 0.4 on that one. So he's reading correct. He's reading correct. He's reading correct. This one, he's not reading at all. Now, another way we need to check is from here, which is a common ground. It goes, this is on a through hole, through there, and it's usually the centre terminal, the larger one of the two. So if we go off of there and try and get as best connection you can on here, apply some pressure. Actually, it might be the wrong way around. I can never remember which way around this should go. There we go. .003, so that's a dead short to that one. It's not looking good. Should have been getting the 0.4. And it's a dead short either way round. This is definitely the problem with this alternator. No reading on that one. No reading on that one. Dead short on that one as well. We should have got about 0.4 to 0.5 reading on each of these terminals. To ground. Jumping around, I think it's just a bad connection. 0.02 is pretty much a dead short. Okay, so our rectifier is not working, our diodes have failed. I'm going to be looking to get a replacement one of these, put this in this alternator and get it working again. Like I said, you can replace these individual diodes, however I think that looks like it's going to be a lot of work to do that, and this is actually pressed together, this unit. So these ones you could get to, but these ones at the back you would have to somehow get this apart. Not worth it. Buy a replacement. Okay, that's it. Thanks for watching. This is my fault on the alternator. I hope that helps someone. Thank you. Okay, I've disassembled another alternator I had, which also had problems. This one happens to be the actual brushes have expired and burnt out on this one. However, it's got a good rectifier in it, and I just wanted to show you how to test the rectifier and what it should look like if it's working. Again, we go on to diode mode on the multimeter. We hold ground onto the post there. Should get about 0.5 on each of the terminals. And if we go the other way around, go onto the ground there, we should also get 0.5 onto each of the 4 terminals. Slightly under on that one. Anyway, they're all around 0.5. So this is a good rectifier. I think it might even be exactly the same as the other one. So looks like I'm going to be able to repair one alternator and just order parts for the second one. Okay, thanks for watching.